No. All right. In goal 9.4, we are continuing with one variable inequalities, except this time it's going to be a quadratic inequality. So that means that there's going to be a power on the inequality that we have, okay? So, before we begin this, though, I'm going to go back to when we solved quadratic equations, because there's some similarities, there's some same things you have to do, and then we're going to kind of build on that, okay? So, let me just give you an example. X squared plus 7x plus 12 equals 0, okay? So, back in goal, I don't even know, 4 something. We did questions like this. So when we solved these questions and we had a power, we had to get it equal to 0 and factor it, okay? So you can just watch because we're going to do the same thing in just a second. So we had x times x, our signs were positive, positive, and 3 times 4 gave me 12, but also gave me my 7 in the middle. Then what did that make my 2 solutions? So what solution did I get from that one? Negative 3. And then the other one I got a negative 4. So we used that shortcut where we took the opposite sign and we went negative 3 over 1 and negative 4 over 1. Okay? I'll give you another one real quick here. Got this written down here. 6x squared minus 7x minus 5 equals 0. Okay? So it's equal to 0, so we factored. So we took 6x squared and we decided whether it was going to be 6 and 1 or 3 and 2. Pick one, try it. Minus last term meant one of each sign, and then 5 times 1 is my only option for 5. And then we checked to see if we were right. So outer times outer, negative 3. Inner times inner, positive 10. 10 and minus 3 gives me 7. But I want negative 7, so our rule was to just switch the signs. Okay, so that became my minus and that became my plus. So then, what was my solution from that one? Positive 5 over 3 and negative 1 over 2. Okay, so I'm remembering that a little bit because we got to do it again. Okay? So when we did equations, these were my solutions. But now we don't have equations. We want to know all the x's that make it greater than 0. These are the x's that make it equal to 0, but there's a lot more that would make it greater than 0. So the process, while we're going to have to do that, we're going to add to it. Okay? Okay. So first example here. I have everything on one side. 0 on the right side, so you want that to happen every time. If it's not, get it into that form. Okay? So, we factor. So I have x times x, only choice, minus last term, one of each sign, and a minus 3 and a positive 2 will give me that negative 1 in the middle. So, what would my solutions be? This one would give me negative 2, and the other one would give me positive 3. So you still have to find your zeros. You still have to find the zeros. Okay? So it's kind of a weird process to get our answer, but this works really nicely. Okay, so you draw a number line. We're not actually going to graph, we're just going to use this to get our answers. And you put your 2 zeros on the number line. In the right direction, or in the right space, of course. Numerically correct. And you pick a number. Now what happened here is I've kind of divided my number line into 3 pieces. So we're going to talk about all the numbers that are here, and we're going to talk about all the numbers that are here, and we're going to talk about the numbers that are here. So a number that's smaller than negative 2. It doesn't matter what it is. Negative 3. A number between negative 2 and 3. I always use 0. 0 is an option because 0 is an easy number to work with. And then a number greater than 3. 4. Now again, it doesn't matter what number you pick. You don't have to have the same number as anybody else. just so it's a number that's smaller than -2, a number between -2 and 3, and a number greater than 3. Okay, these are my test points, okay, my test numbers, I should say. So we're going to take each number and plug it into the factored inequality. Okay, so when I plug in -3 here, -3 plus 2, what do I get? I get a -1. Now what matters about that answer is simply the sign that you get. That's why the number doesn't matter. So I don't care if you put -3, -4, -5, -12, -126. No matter what you put, no matter what number you put, when you put it here, it's going to come up negative. And when I put it here, -3 minus 3, I'm going to get a
0.
no.
What time?
I'm going to get -6. I'm going to get a negative. I'm only worried about the sign. So when I take a negative times a negative, I'm going to end up with a positive. Okay, so let's put 0 in. And again, I don't care what number you're getting. I want to know what sign you're getting. So when I plug in 0 plus 2, I get what kind of number? A positive number. When I plug in 0 minus 3, I get a negative number. And a positive times a negative is a negative. Plug in 4. 4 plus 2 comes out what kind of number? Positive. 4 minus 3 comes out what kind of number? Positive. And a positive times a positive is a positive. So what this tells me then, this little work I did in the pink, is that the numbers over here, less than -2, whatever number in that area is going to end up positive if you plug it in. And the numbers right here, when we plug those in, they're going to end up negative. And whatever numbers I pick over here, they're going to make it end up positive. Okay, does that make sense so far? So then I go back to my question. What am I looking for? I'm looking for the numbers, the x's, that make this greater than 0. And greater than 0 is a positive number. So we go back to our little chart thing here that we just made. And where are the positives? As we just said, they're the numbers less than -2, which looks like this. Negative infinity up to, got my negative, -2, unioned with, because there's another piece that gives me positive, +3 up to positive infinity. Now, be careful, because when you write your answers, you're using the zeros. You're using these numbers, not your testing numbers, which people commonly, not commonly, but if they make a mistake, they write those testing numbers. They're the zeros. So the numbers smaller than -2 and the numbers bigger than 3 are going to make our answer positive. So that's my final answer. Yes?
So as soon as we get the two numbers, we know that the lower one is going to be with negative infinity and the positive one is going to be with positive infinity.
Say that again?
So if we get the first, or if the lower number is negative and the higher number is positive, it's always going to be union infinity with the lower negative number. Why not?
I don't think so. Maybe I don't understand what you're asking.
Because if you multiply, oh wait, never mind, because the top numbers are always
Okay, let's go to another question. Sometimes this takes a little getting used to. You've probably not seen this before. Okay, so I'm going to factor. It's less than or equal to 0, so we want that 0 there. It's got to be a 0. That's there, so we're ready to factor. Okay, 3x squared, 3x and 1x. Only choice. Minus 1 of each sign. 5 is going to be 1 times 5, 5 times 1. I can already see where it's placed, so I'm going to do it right. Check to make sure you're correct. Outer times outer. I did it wrong. It's -15. Inner times inner. +1. So that's a -14. I want a +14. So I'm going to switch my signs. Now I got +15 minus 1 gives me 14. So my zeros are positive 1/3 and negative 5. So I find my zeros, because those are the numbers I use on my number line for my boundaries. So negative 5, positive 1/3. Okay, so a number smaller than negative 5, I just go to the next number. A number between negative 5 and 1/3, I always choose 0 if it's possible, because that's easy to work with. And a number bigger than 1/3, 1. There's times when you do have to use fractions. I'll get to that. I'm pretty sure I got an example like that. Okay, so let's plug in our test numbers. -6. And again, we don't care what the number is when you plug it in. We care what sign it is. So 6 times -6, or 3 times -6 minus 1 is going to be a -19. So it's going to be negative. -6 plus 5 is going to be a negative. And a negative times a negative is going to be a positive. When I plug in 0, 3 times 0 minus 1 is negative. 0 plus 5 ends up positive, and that's going to be a negative. I'm going to plug in 1, 3 times 1 minus 1, positive. 1 plus 5 is a positive, and a positive times a positive is a positive. Okay, so we want the numbers, if we look back at our inequality in the factored form, we want the numbers that are less than or equal to 0. So that means negative numbers. The negative numbers are going to happen between -5 and 1/3. I will include those this time though. I will use a bracket because we have the less than or equal to piece. So -5, including -5, up to and including positive 1/3. So again, this time I'm looking for the negative numbers. That's here. It is less than or equal to those, so it can equal 0, so we do include our boundaries of -5 and 1/3. What do you want to ask? You have a question?